All right, and we are live. Cool. I'm getting better at this.
That's good.
Awesome.
Yeah, this is going to be tricky. It's quite nerve-wracking being the recorder guy, you know?
I'm just glad I know how to do this because before in another class, I did have Google Hangout too, and I'm like, I have no idea how to do this. They're like, oh, you have to go to YouTube and you have to do this. And it's just going in one ear and out the other for me, but I'm getting better, so I'm happy about that.
That's good. Okay, let me just open the quiz. Oh, sorry.
Yeah, how's everyone holding up on all the information?
I must admit I struggled with getting this part. Just nothing seems to be sinking in.
Yeah, no, it's definitely some hard information.
A lot.
I kind of want to know the why behind everything. Like, why do any of this? That too. Why make it complicated? But why do any of it?
Why do we need the mean of the mean? It's just mean.
Yeah, why do we need that? There's some unanswered questions here, and I want to know the answer too.
Well, Gabriella, it's your thing, so tell us what we're doing.
Well, you guys all on the quiz now? I just like starting right with the quiz.
Okay.
Unless you guys had any questions or concerns or anything.
Yeah. So you're waiting for us to start the quiz. Let me just get in there.
Yeah. If you could, just let me know when everyone's there, and we'll go ahead and do that. I'm already on question 4.
Okay. Okay.
Okay, so we're starting, eh?
Yeah? You got the quiz open?
Yes.
All right, good. Everyone has the quiz open then?
Yep.
All right, first 2 are to you guys, and then someone want to go over question 3?
Show you my awesome new Wix website. It's got everything I
guess I can.
Okay.
Use the normal probability applet to find the combined area under the standard normal curve that is to the right of Z, so Z, which is 1.358, and to the left, minus 1.358. Round your answers to 3 decimal places.
Is it 0.826? Is that right? Gabriella, is that what you got?
I did not get that. I got 0.1745, and I'll show you.
Yeah, because it's the 2 shaded areas on the 2 sides, am I right?
Using normal program.
Because let's see the number. Did I get my number right? Yeah, 1.358. Yeah, 1.358.
1.745. Is that?
No, it's 0.175 if you're gonna round.
Yeah, 0.175 because we're rounding.
That's what I'm saying. Sorry, yeah. 175.
Yeah, no, you're good.
I just didn't subtract 1 off it, so that's why.
I see. All right, you're good.
So I make videos, and I have hundreds of them online. Everything's synced
All
up.
right. Is everyone good right there? Does that make sense? I'm sure that's the answer.
Well, if you all got it, I'm pretty sure it is.
All right. Dion, you want to do 4?
Okay. Which of the following will have a smaller standard deviation of 9 observations are randomly drawn from a population? The distribution of the deviation expression x, or the distribution of sample mean x bar. This cannot be determined from the information given. Smaller standard deviation.
Yeah, this is one I didn't answer yet.
It should be x bar though, isn't it? Because it's the square root. It's the value divided by the square root, so it gets smaller. The standard deviation for the distribution of x bar is smaller, isn't it?
I think that's right. Let me check real quick in the book. Let's see. Yeah, I think that's right.
So it's an x to the bar, eh?
X bar. All right. So B is the answer that we have for 4.
Yeah, so which of the following results implies that the spread of the x bar decreases as a sample size increases? Cool.
Sure. Multiply the spread.
Distribution.
Isn't that the second one?
No. Isn't it? What does the central limit theorem say again?
Oh, let's see.
It's the larger the population, the more normal the shape of the distribution.
Mm-hmm.
Something like that.
The sample mean is normally distributed.
So when the sample size is large, that's the central limit theorem.
And it's normal. Let's see, the population is normal and the sample size is large. I think is what it is. Or no, the sample mean is normally distributed.
Isn't the central limit theorem? Is that the right answer?
Let me click. I might have got my vocabulary wrong. Let's see. Let's see, central limit theorem. The distribution of sample means is normal when x bar is normally distributed, or when, thanks to the central limit theorem, our sample size is large. Oh no, I was okay.
So which do you think it is?
Maybe central limit theorem. It's not the 6895.
What the central limit theory says is that it's normally distributed.
Yeah, it doesn't.
There's no mention of being normally distributed in this example.
But it speaks about the sample size in the central limit theorem.
Let's see. I think central limit theorem is partly correct, but not our best answer. The law of large numbers says that the sample size gets large. As the sample size gets larger, the sample mean will get closer to the population mean.
That's the right answer then. The law of large numbers.
Yeah.
Great.
Yeah. All right, we're good. All right, I'll do the next one. Oh, next 4 questions are supposed to use this info. Okay, scores on the quantitative portion of the GRE are approximately normally distributed with the mean 150.8 and standard deviation of 8.8. All right, question 6 says, Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diana's score?
Okay, let's see. So that's...
Okay, so our X is the 160.
Yeah, 160 minus 150.8 divide by 8.8. That gives us 142,864.
What's that?
142.864.
Let's see. Is that our z-score?
I'm asking.
Oh, let's see. I need to look up.
So the formula is x minus the sample mean divided by the standard deviation. So that's x is 160 minus 150.8 divide by 8.8.
Isn't it yeah.
Square root.
Yeah.
But is this the did I score? Portion?
Let's see. I'm checking real quick.
But this is not asking for the mean of the mean, is it?
No, it's asking. We just want the z-score.
So that's the old, chapter 4, chapter 5 stuff. It's not chapter 4 stuff, not chapter 6.
Let's see. Here's our z-score here, but we don't. I don't think we have
It says
n.
Z equals x bar minus that funny u thing, divide by the deviation by this divide by the square root of n.
But that's if you want to get the sample mean.
We
The
don't.
z-score of the sample mean.
Yeah,
but we're
and
not
we
doing
don't have n right now. So it's just the regular z-score formula, the x minus mean over standard.
So for the next question, we just enter that z-score. No, what did she? That can't be the z-score. That's too much.
Yeah, it is a lot. You can't.
Wait, no, that's wrong.
That's there's something. There
Sorry,
is something wrong there, though.
I did something wrong. Sorry, 160 minus
1.045.
Yeah, 1.046.
That's what I got right there.
That's 1.406, correct?
See, how'd you do that? Because I took the. I have a different number than you,
No,
Dion,
so-
but
so
I
the-
took the.
So the answer is 1.045454545. So 045, but you have to round the previous number to 5 and you round it to 6.
You round the 5 to 6.
Yeah. Let me show you. Let me just get this on.
But there's a 4 in front of it.
Yeah, but that's what I'm saying. So you have to take 045, and then there's a 4, but the 4 becomes a 5 if you round that, and then it's 5 rounding up to 6.
Okay, but wait, don't we want only 3 decimal places though?
Yeah, but don't you use the previous numbers to round to those 3 decimal places?
I don't know. I'm putting down yours. I'm putting down your number.
Let me Google it.
Okay.
I don't think you round. If you want three decimal places, you only take the 4th one to round up. You don't round everything up.
Use Excel.
That's the easy way. What does Excel say?
Numbers are fun.
I'm just entering it in Google. I've got a thing here that's going to tell us. Value 4.5. It says 4.5. So that's something new for me. I always did it like that.
Oh,
Okay,
okay.
so it's 4.5 according to this thing.
So
Yeah,
it's
0.045. Okay.
They shouldn't really give answers like that
Huh?
because it's ambiguous. Okay, let's see. So
And then we're just using for question 7. It says, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So everyone knows how to do this, right? How to do this question. I know how to do this question, but does everyone else? Because we're using the probability applet for this one.
Yeah, so you just put in the z-score.
Yep, and
Yes.
then you shade up because we want to know
above.
above, and
So
doing that, it's 0.148.
that's what I've got.
Yep, awesome. Someone want to do question 8?
A random sample of 5 students was selected to take the GRE. Their scores are, those are the 5 scores. What is the z-score corresponding to the sample mean of these students' scores? So we'll have to add all of those and then divide by 5. So the mean is 160.
Yep.
And the z-score is...
The z-score is the same, isn't it? Because if we're using the same numbers for the next 4 questions, which this is still in it, we just barely found the z-score when x was 160.
No, isn't this new information? Oh, so it's still the same. Okay.
Because if you add up all those scores, it's
800.
then you divide by 5, which is 160. And the mean is 150.8, so it would be the same z-score.
It's the same z-score.
1.045.
Uh-huh.
Isn't this looking at the mean of the sample mean now?
This is the mean of the means.
No, this is not.
No, we just they just want to know the z-score, but it's the exact same one because our mean is
It hasn't
160.
changed.
Yeah.
So we're saying the z-score is 1.045.
It's the same number. All right, someone want to do number 9?
Is it my turn?
I think it's just changes.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answers to 4 decimal places.
So now that is when we use that complicated equation where you divide it by something over the square root of 5, right?
Because 5, I think 5 is the n.
Yeah. So you'd say, so it would be 1.
So are we sure that z-score is correct then for the previous one if we think this way about this question?
If anything, I'm 99% sure.
Okay. 5 random selected students will have a mean score that is great.
So then it would be what?
Shouldn't we calculate the take the z-score for both answers, meaning for both values, and then subtracting the percentages on the top of the box of the applet, and then that is our answer, like we did last week.
I'm not sure we're supposed to be doing that.
The thing is, now we're going to get a different z-score for this. So you're right, but we're also going to get a different z-score because now we've got the number of students we're randomly working with. So that's that z-score equals x bar minus the mean divided by the deviation divided by the square root of 5. If I'm understanding it correctly.
Yeah, we are using that crazy equation. All right, let's see. Let's see if I can do this on my phone.
I'm not sure that. Yeah, it won't work the other way. Okay. Let's just see. So what we're saying, it's z equals x bar minus the mean divided by the standard deviation divided by the square root of the sample mean of 5. So
I'll show you what I have.
So x bar in this instance is 160, correct?
160.
Yeah, so it's 160
Minus 150.8
Minus
divided
150.
by
8.8 divided by square root of 5.
divide by the square root of 5.
Mm-hmm.
Sure, that's quite something. Let's see.
I got 2.337 for the answer.
You said divided by the square root of 5.
Yeah,
I got 2.337.
7.
So it's 338. What did you get?
To round to 4 decimal places.
To
So
4 decimal place.
2.3377.
That's correct. That's what I'll say. Just didn't round it properly. So 4 decimal. Why change the?
So I want to make sure we're reading the questions.
377. Well, I believe you guys.
Okay, I got 2.3374.
Oh,
Well, that doesn't change your answer regardless, though. I got 337407431. But it doesn't change the answer. It's still the same because we're rounding.
Yeah, so 2.3374.
No, it's 4 decimal places.
4 decimal places.
2.3377,
Yeah.
not 74.
Then perhaps somehow I did my stuff wrong. But I feel like I did the same thing you guys did.
Because it was 160 minus 150.8.
Yeah, and that's 9.2.
Yeah, divided by 8.8 divided by the square root of 5.
8.8 divided by square root of 5 is 3.936. So this guy divided by this guy is this guy.
Maybe you need to charge your phone.
Yeah, we get to continue.
All right, yeah, let's continue. So apparently we need this information below for the next 5 questions. So suppose the mean GPA of BYU Idaho students is 3.5 and standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of N81 students will be drawn. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of 81 students who are selected?
Normal.
Is it normal?
I don't know, because it says it is
Left
well known
skewed.
that
Yeah, the thing says it's left skewed.
But it's a large sample.
Yeah.
Well, that's
Yeah.
true. That's true.
So
All right,
it's-
I'm gonna put normal,
Approximately normal.
approximately normal.
It sounds approximately correct.
It's approximately correct. Oh,
What is the mean of the distribution of this? Let me read the next one.
okay.
What is the mean of the distribution of the sample means? So that's the new formula, sampling distribution for all possible samples of size 81 that could be drawn from the parent population. What does the mean of the distribution mean? Okay, well, that's not, so we need to, the mean of the distribution mean. That's can't remember.
you can't use the new calculation.
But there's another one. There's that other smaller formula that we learned this
Yeah.
week. Just want
The standard deviation divided by n.
to, yeah, square root of n.
Yeah, square root of n.
Yeah.
So what that would be?
Just to make sure.
Standard deviation is 0.7.
0.7 divided by the square root of 81. Would give 0.1 because I want 1 decimal place.
Yeah, it would give you 0.1.
But I think 0.1 is wrong.
Hmm. What else could it be then?
That's why I said I think it's wrong. Although maybe because the deviation is 0.7, so maybe it is right.
No, I think so. The in the book it says the standard deviation of the random variable x bar is standard deviation over the square root of n.
Yeah, that's what I'm just looking at as
Yeah,
well.
so we did that. We did that right.
So what did you say the answer?
0.1.
0.1.
0.1.
0.1 or 11.
Well, they want 1 decimal place.
Yeah, just wanted 1 decimal place. It's kind of funny. Okay, someone want to do question 12?
Yeah, I'll do it. What is the
Okay.
standard deviation of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
Is it the same again?
Yeah, is it the same?
What is
Yeah. 0.1. Actually, well, in this instance, it'd be
Because 11, they were asking what is the mean of the
Mean,
distribution.
need the standard deviation.
And in 12, they're asking for the standard deviation.
That's
So
0.7.
Standard deviation.
So now we're working out the squiggly O thing.
Hmm. Let's see. This isn't the same question, right? 11
it's
and
not.
12.
No, it's not. One is asking for the mean, and the other one's asking for standard distribution. So the one that we answered 0.1 is that not standard distribution?
No, for the last one we did the standard deviation. So the 0.1 is actually the answer for 12, I think.
Yeah.
And then 11, it's just 3.5 because the mean of X bar is the same thing. Plus, it also follows with the rule in question 11 that it just wants one decimal place, 3.5.
So then, if we're answering question 12 with the calculation we did for question 11, then the actual answer is 0.078 because it wants 3 decimal places. Am I right?
Let's see. Yeah, 0.078. Yeah.
So is it 0.1? What's number 12? Just repeat that.
Because we want 3 decimal places.
Yes. What's the answer?
0.078.
0.078.
Yeah.
That's only 2. So see, I haven't calculated. Let me just calculate it.
0.078. That's 3.
0.078. Just tell me the formula again for that one.
Okay.
It would be
what was
0.7 divided by the square root of 81.
Mm-hmm.
Oh, I see.
But now we're back to being stuck on question 11.
No,
we're done with question 11.
No, we're done with question 11 because the question 11 is just 3.5. The mean of X bar is the same thing.
Okay, so the answer for 11 is
so it's 3.5.
3.5.
Yeah, it's 3.5.
See, Adrian, here, this is why I'm asking. So the answer to number 12 is 0.0777778. So if what you said previously about rounding is true, then the answer should... No, sorry.
Yeah, but you're taking
0.78. I'm right. Sorry, I just had a wobbly.
Okay.
So 11 is 3.5.
Yeah.
Yes.
Okay.
All right.
What is the probability that the...
You want to do this one, Dion?
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Do we need to find out the Z-score?
Yeah, it'll be...
So we find out the Z-score and put it into the applet, am I right?
Yeah.
Yeah.
What's the probability of the mean? That's using the normal formula, isn't it?
Yeah.
I think so, yes. Yeah. The Z-score. Well, let's see, I'm trying to do the math here.
And we'll use 0.7 as the standard deviation.
Yeah. Yep. What are you getting for the z-score?
Minus 0.2857.
Okay, that's what I got too.
Sorry, 2857. Sorry, I don't know where I went.
So then the probability is 0.3874.
Is that in the applet then? Eh?
Is that what
Yeah.
the applet says? Yeah.
So that's
What did you get?
Yeah, the 0.387. And you made sure to shade the 2 to the left, right, Leon?
I just shaded the one to the left because it's asking. The question is, what is the probability for racial exclusion will be less than 3.3? So it's a
Okay,
minus.
okay, good.
the
To the left.
minus one, right?
Yeah.
Good.
So you guys got 0.387, eh?
Uh-huh.
Yeah. The next one is easy.
But
Will be greater. Yeah.
now we're coloring the middle and the right hand side, am I right?
Yeah, middle and the right.
Or subtracting 1 from the previous number.
That too.
So 613.
Right, 0.613.
Mm-hmm.
Very cool. Question 15. I'll read this one. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. Standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability the random sample of passengers will have the weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. And we're looking for 3 decimal places.
What about 0.000?
Yeah. Oh, jeez.
That's probably what it's going to be.
Right. Oh.
So that's that hectic equation, right?
Yeah, this is crazy.
So the note says, as extreme and more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours. Okay. So we're looking for the middle. I'm guessing we use the applet and we're looking for the middle one, I'm guessing.
Sure, I don't understand what to do here.
I want to say we find the z-score.
Yeah, I get a z-score of 1.920.
How did you calculate that? What did you do? Is it a one of the funny z-scores?
Yeah, so I minus 185. So 185 minus 177.6 divide by 26.7 divided by the square root of 48.
Is that correct? Because that X bar value, which one is that? Isn't the X bar value the sample mean? Which is
I want to say that's it. The sample mean is the the one you put in the first of the equation.
So which is that 177.6 or
Yeah, 177.6, then subtract
185?
yes, 185 divided by 26.7 divided by the square root of 48, I think.
Yeah, that's Aiden, that's different to yours. What do you think?
Just finish calculating here.
This one's a little tricky.
See, this is where multiple choice is very nice.
Right? Yeah,
So I've got
geez, I wish
I've
this
got a
one was
minus
tricky.
1.920.
Yeah,
Zero.
920.
Minus 1920.
Yeah, that's what I got.
All right.
I just had a positive one because I worked out the equation the other way
We
around.
did it the other way around.
So now
Alright,
which one are
that-
you feeding in?
That
The
should
middle?
be it. 1.920, that should be it.
So now, find out the probability of random persons who have a weight that is as extreme or more extreme. No.
All right, is everyone okay with that, or are we still stuck on this?
So what answer did you get, Gabriella?
The 1.920
A negative or positive.
But is
negative.
are they asking for the z-score?
They want, it says find the probability that a random sample of passengers.
That's the z-score. Okay.
So that's only the z-score. So we need to take it into the applet then, isn't it?
Yeah.
Yeah,
Could you-
plug it into the applet, yeah.
But what part of the applet do you color in though?
Okay, that's where find the
Between
probability
it.
that a random sample of passengers will have a weight that is extreme or more extreme above or below the mean.
So the middle, I'm guessing the middle of the applet is what we shade. And inputting the z-score and shading the middle of the applet, it gives us 0.945. Yeah. So I think that's our answer, the 0.945.
But that would mean that 94% of the passengers have extreme or more weight than they're supposed to. So 94% of the 48 random people have extreme weight.
Okay, the sample.
Huh.
So shouldn't we mark the two ends of the Quizlet instead of the middle? So don't mark the
Maybe,
middle.
yeah. Actually, yeah, maybe I'm thinking backwards here.
So isn't it 0.049? 0.549.
Yeah, but they want 3 decimal places, so it'll be 0.55.
Yeah,
Yeah.
0.55.
0.0.
All right, that actually sounds better.
This almost sounds like we're talking about grammar or something.
Yeah. Oh.
Are we brave enough?
Yeah, I'll do that. I'm okay with this if you guys are okay with this.
Let's all submit then.
All right. Everyone's questions are saved. My questions are saved. Gonna submit it. Come on, computer.
Oh, we got a few wrong, eh?
Oh,
Ooh, looks like it. Yeah.
that's
We got the
okay.
last one right, which is
Oh, the
good.
last one right. That's nice.
Luckily, I haven't submitted yet.
Don't be like that. You can submit the next one.
Answers, man.
You can submit the next one then, and then we've got another chance. You see?
Okay.
Yeah. All right.
Oh, have you stopped
Well,
the recording already?
Nope. I'm gonna do it now though, because I have to go, and so I'll stop the recording. I'll submit it.
Okay, so which ones did we get wrong, Dion?
We got. Let me just go from the top. So we got.